Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Welcome to the Uptime Wind Energy Podcast Spotlight. I'm your host, Alan Hall. Today, we're diving into the costly challenges plaguing wind farms with Lars Bendsen from AC883. From a surge in severe lightning strikes to devastating turbine misalignments, Lars reveals why seemingly minor issues can lead to catastrophic failures and how cutting-edge solutions like nacelle-based LiDARs are transforming maintenance strategies. Plus, discover why Lars believes too many industry tourists are making decisions that cost operators millions in unnecessary repairs. So get ready for a no-holds-barred discussion about what's really happening in wind farm maintenance. Lars, welcome to the Uptime Wind Energy Podcast Spotlight.
Thank you so much. Appreciate it.
Well, you've had a busy blade season, and you've had crews all over Canada and parts of the U.S. What kind of problems were you solving with your blade crews this year?
That was a crazy repair season, and it's not to feed directly into, but we had a ton of lightning strikes and lightning repairs, higher than I would say the average. And some of the strikes were severe. So I don't know, you probably know better than me, if the weather pattern has been leading up to better or worse. What we do know, we had a really wet summer. We had a ton of weather delays. We had a ton of high winds. We have a ton of rain. So we had our standby time was higher than usual, and that's annoying for everybody involved. Owners don't get their job done, and money is flying out the window. So, and we don't get the job done either. So it's really wet that way. So I don't know if that's the aftermath is going on over the winter. I have no idea, because you can't really see when the strikes was there. And the owners have a system that can measure when it comes, but I don't think they're looking at it.
That's true. We are seeing more lightning strike damage over this past summer. It's been really bad. I think it's just the set of storms that came through. But in your case with AC883, when you have technicians on site, you're bringing high quality sort of apprenticeship plus technicians that have a lot of training, so that when you get into these complicated repairs, you can actually accomplish them properly.
Yeah, we're getting our people mostly from Europe, simply because there's no availability for staff in Canada. So we get them in from Europe on a proper work permit, simply because we are short-staffed. We do pay more. We also get GWO certified technicians, all of them. And last year we had about 60% that could do Cat 4, Cat 5. Next year they're all doing Cat 4 and Cat 5. That means on some simple LEP work we could maybe be either earning less, or we might be a little more expensive or regular LEP work, because it is highly trained technicians. We learned from last year, based on the percentage of Cat 4 and Cat 5 damages, we simply need to have more flexibility, so we will only have Cat 4 and Cat 5 technicians.
Do you think there's more Cat 4, Cat 5 damage lately? Because that's what I think. I've seen a lot more over the last couple of years.
Yeah, from 23 to 24, there's a significant increase. If it's really high lightning strikes, damages, from tail to head split, everything.
Yeah, is that driven by just the lack of understanding that what looks like to be maybe a small pinhole in a blade is really much larger, and the operators don't catch it early enough, or is there other factors involved there?
I don't know. I think it might be that, everybody knows that all the engineering departments, all owners, are really lean, or in best case lean, but mostly understaffed. So that means the poor guys, they are struggling to keep up with everything. They can't see it. And I have a strong opinion about the drone inspection all the time, because the AI and the pictures, you cannot run on an autopilot. You cannot just take a picture, see, that's it. You can't. You simply have to get up there. We had minimum 10 blades where it was simply just a grease spot that was categorized as category 4. We also had the opposite, where just a grease spot was actually a lightning strike. So we had it all over the place. So you cannot run on autopilot.
That's interesting because I've heard that same discussion from a couple of operators about whether the drone inspection categorization has been correct. I think as the lightning strikes get more frequent, we're seeing what looks to be smaller damage further down the blade, which would typically be grease. Especially as you get closer to the root of a blade, you always think, well, that's grease from inside the nacelle that's fallen onto the blade. Don't worry about it. But in reality, I think we're seeing more lightning strike damage in more critical areas that lead to this Cat 4 and Cat 5 issues.
Well, you've seen it very often as well. It's a small lightning strike. Once you start opening it up, then you are 16 layer deep. Just an example, right? So we had some of them that looked very small, and then you're ending up in a $70, $80, $100,000 bill, right? Even though it looks very small. And therefore, go ahead. No, I'm just saying that's why I personally, I know there's a ton of opinion about it, but I personally don't think you can run on autopilot. Which also go back to we've been involved in robotics as well, robotic repair and all that jazz. And I know there's a place in the market for it, absolutely. But based on our experience, pure LEP and nothing else is only having maybe 10% of the blades. There's always something to look for. There's always an extra damage. There's always something. So we have to get up there anyhow.
Is that because the industry for the longest time has only inspected like a third of the farm at a time? So it'd take 3 years to really get across the whole site. So if you did have damage, it may have sat there for 2 years before anybody even could identify it. Isn't that changing a little bit, though, that I'm meeting operators that are doing a lot more inspection and trying to catch these problems early?
No, and I agree, and I agree on doing the drone inspection. Do your whole fleet every year. Just do it. It's peanuts compared to whatever. But that said, I think it's great with drone inspection, but you cannot rely on 100% autopilot. Somebody has to look at it with qualified eye to look at it. And it's better to climb one blade too many than one too little.
So the question in my mind when it comes to lightning damage up in Canada is because it's so cold and there's so much freeze-thaw that happens up in Canada. Is part of the issue that once you have this wound in a blade that just the freeze-thaw over a year or two can really expand it and then cause trailing edge separation and all those sort of horrible things that happen to blades?
Well, I guess as soon as you get water inclusions, then of course up here, water had a tendency to get stiff under 0 degrees C. So of course, then you have an issue.
That leads into the discussion about, well, it's cold in Canada, which means you guys get the winter first, and then it comes down our way because we're getting close. Which then gets me into its pitch alignment and sort of yaw alignment season for you, because it's nice to have the fields sort of knocked down and everything frozen. Pitch alignment is a huge problem. And balancing is a huge problem too. What are you seeing out in the field right now?
Well, I'm seeing that owners relying on OEM statements that we can do pitch correction in our controller, we can do extract, we can do automatic yaw alignment, which is questionable, and put it that way. And I said, my new word is there's too many tourists in this. It is in the industry. They're tourists. They simply don't know what they're talking about. They come and look at it. It looks nice, but they actually don't know what they're talking about. A yaw alignment is one thing, but say we can correct your yaw alignment. No, you can't, because you can static align your turbine. But turbines are misaligned differently in different wind bends. So you need a dynamic yaw alignment, not a static yaw alignment. And the only thing you can do is static. You cannot do any dynamic yaw alignment. Very simple. Just to give you a brief, I mean, the equipment sitting behind the rotor, that means the anemometer, cup anemometer, sensor, whatever you have, is sitting behind the rotor. That means it's sitting in turbulent wind. And it's always chasing whatever has happened already. They get the information later and then try to chase the wind. there are some OEMs that don't, because you cannot yaw all the time. Then you're going to wear out the yaw bearings and brakes, etc. So, but there's also some OEMs that they're allowing up to 7.9 degrees before they do anything. And then they have, when you boil an egg, you have a watch starting. They have a counter for 30 seconds. If it stays above 8 for 30 seconds, they start yawing back towards 0. And that's the better one of them. They're doing that. So that's the dynamic yaw alignment that you need to have. We have no stake in LiDARs per se. We know them, we work with them, but we don't have any monetary stake in it. But you need a nacelle-based LiDAR, basically, if you want to run optimal. That means you're measuring 80 meters in front of the turbine in a clean airstream. That you get a way more accurate wind speed and wind direction measurement. And then you connect that to the controller, and then that control your yawing. You're not changing any yaw strategy. You're still doing the same. You don't overdo the yawing. You just want to make sure that you have a more accurate read on speed and direction, which again feeds into your pitch.
Yeah, let's talk about LiDARs for a minute, because I know you and I have had a couple of discussions about LiDARs. I don't see them used very much in the United States at the moment, because I don't think people really understand them of how they can use them for operational purposes. I think they see them as sort of a calibration issue, and then once they're done, they kind of move on. But you're saying that LiDAR can really improve your operational performance.
Oh, absolutely. You have, of course, I think it's misinterpretation, because there's basically only one supplier of nacelle-based LiDARs. There's a ton of ground-based LiDARs. There's measuring up and kind of measuring in a cone when you do site assessment. And that's totally good for that. But this is nacelle-based LiDAR, 2-beam. They can also get into 4 beams, so we can measure wind shear. But for operational purposes, it's actually more to get the wind speed and wind direction more accurate. And that is connected to the controller it doesn't matter which controller, and that means that will do your yaw alignment in each wind bin.
Okay, so the LiDAR is acting as an alignment tool constantly to try to correct for what the OEM equipment didn't do.
It's kind of a third party, call it anemometer, just measuring 80 meters out in front of the turbine. And it does more accurate because it is laser, basically, right?
Right. And the implementation of LiDAR on turbines is what? Does every turbine have a separate LiDAR, or is a LiDAR good for a couple of turbines around it?
No, you do it on every single turbine, because you cannot remote control. You cannot remote connect to every turbine's controller. We have to be connected to the controller, and it's very simple. We do 2 turbines a day, so it's not a big thing to do. It takes a couple of hours to get it aligned, connect to the controller. It's very simple, actually.
What does that process look like? Because now you got me curious. I'm taking this LiDAR unit, I'm bringing it up tower, I'm mounting it to the top of the nacelle, I'm maybe doing a little bit of alignment to get it focused in the right place, and then I'm plugging that into the SCADA system, the control system?
In the controller itself.
Oh, in the controller itself.
Yeah, and it's a fail-safe system. It's running on different bus connections. It's too technical also for me, but it's a fail-safe system. So if something goes wrong with the LiDAR, or the LiDAR can't see heavy fog or something like that, then it goes back on the controller, on their own original anemometer. So there's no danger to it. Right now, we have huge success on V82 in the US and Canada. The V82 is a bit of a different animal because it's a stall-regulated turbine. But again, I talked to a colleague of mine and said, well, that guy who changed the algorithm, he was not working that day. So it's not very accurate. It's not. So that's one thing. So V82 specifically, and also an interesting is that when a V82 running above rated wind speed, it very often comes up with an alarm and shuts down. So what we are doing, it's running down on a ton of vibrations. That's why it stops. So we are misaligning the turbine on purpose above rated wind speed. Below, we are running as close to 0 as we can, but above rated wind speed, we are misaligning the turbine. That removed the vibrations, and we also have a less load on that turbine. So we actually opposite what you normally would think.
You can produce more power having a little bit of an offset because the turbine doesn't shut down.
And we have now we have of the more than 200 turbines we have outfitted in Canada and US. We are seeing say AP gains of 2.8 to 3.5% AP, and that's without the extra uptime. That is just because of AP power.
That's remarkable. Getting 1% today can be a lot because the turbines are usually pretty good. But if you can squeeze out more than that, that's remarkable. Where is the LiDAR generally used at? What kind of farms would be interested in LiDAR? Is it kind of ridgeline farms, or the wind can be a little more unique, or is it in the flat plains of Kansas and Oklahoma and Canada?
Well, of course, the more obstacles you have in front of your turbines, the worse it gets. I've seen down in Mojave Desert actually on a site down there. The turbines on the same side are basically 90 degrees misaligned from each other, but they're both right. They're well aligned, but of course the wind is simply coming around like that, so it looks weird when you're driving there. They're 90 degrees different on the same wind farm, but they're both correct, aligned.
Yeah, I would say something is wrong. Stop the turbine, but yeah.
But no, they're both right. But that is what it is. So that's one thing I think is the critical. We talk about maintenance. Again, back to my old phrase that some OEM have bored, the rotor is the motor. And it means if the rotor is not aligned in pitch and yaw, mass imbalance, etc., then you're paying for it.
That makes a lot of sense then. So knowing more about the wind with LiDAR what kind of ROI is that on a LiDAR system?
Well, depending on what market you're in, on the AP or the PPA, of course, right? So that's depending on, but we have seen less than a year. We've also seen, depending on what you're in, right? What is your factor up to your capacity factor, your PPA, etc. So it's not a one size fits all. We have to look at it and make smart decisions, right?
Boy, any ROI less than a year, I want to get involved with.
They should actually get fired for not doing it.
Right, you should. That's too easy. Yeah, it sounds interesting. So let's bump into pitch alignment and unbalanced rotors, which are very prevalent. Joel and I were traveling across Kansas and Oklahoma and Texas quite a bit this year. It's fairly easy to see rotors that are imbalanced, or they're just not. You can tell because there's a little bit of wobble going on there.
Yeah, and often you can hear it.
You can hear it. Yes. So what is the solution for that? How do they fix it?
Well, first of all, we have to measure if it's imbalanced and if it's aerodynamically balanced or not. That's number one. Let's figure that out. Do we have the same pitch angle? Regardless of what it is, it has to be the same. And it has to be the same all the time. Actual pitch or not is to be the same. So, and they're not. Based on we have done more than, I think we have 2,500 turbines now in US and Canada. And based on age of the fleet and also the manufacturer, it's a crazy amount. And people, they know it, but they don't do anything. And that's where, back to what I said before about we have too many tourists in our industry. So the decision making, right? So I'm just took my note here. We're talking to an engineering department. They understand it. Engineering have no money. They just have to nod. Yeah, it's good. Passing it down to the site. Site looks at it. They think it's a great idea too. Now they have to sell it to either director of operations or asset management. Some director of operations, they understand it, but if you have money, we can't put it on M budget because that's already cut in to an absolutely zero fat on that bone. There's no money left for anything, projects like that. And then sometimes we go to the asset manager, which might be often, or sometimes is a commercial-oriented person, less technical.
Well, with an unbalanced rotor, it's almost inevitable. You're going to destroy a main bearing set. You're going to probably take down a gearbox with it if you let it go on long enough. And in some of these cases that I've heard, the control cabinets are moving around so much that they're damaging the control cabinets. At what point do you say it's worth I can't replace control cabinets anymore. I'm just going to do a pitch alignment and be done with it. It seems like an obvious choice.
Now, sometimes what we have seen on especially hydraulic pits, that is not as bad as you think, it's way worse. They just have vibrations. So now they buy vibration sensors. Now they look at extra bearings for the gearbox. Now they look at all kinds of stuff without looking in front of your rotor. Look at the rotor. That's the root cause for 99% of your troubles.
Well, I've heard of turbines, not often, but occasionally, where the turbine enters the ground, right? Or the tower enters the ground, that there's gaps, big gaps, like almost a foot wide, as the turbine's been swaying around, is pushing the soil away from it so much, which means that's at that point you have major problems. And I'm surprised I see the technicians, and I hear stories about throw more gravel into the hole that's happened near the tower because the tower's swaying so much. Like that's going to solve it.
It's beyond right. It's just really. When we have, I won't mention name, of course. We have one customer. We kind of rested our case. We can't spend more time. That customer had amount of issue on foundation, even turbines falling over, shutting down sites. Second site they're running, we have evidence that 60% of turbines are misaligned. But we cannot get $100,000 to fix it. You know what? That's fine. We have tried now for a couple of years. We rest our case. We told you, we proved it. We measured 10 of your turbines. We know it is. We rest our case. We cannot spend more time if we don't want to do it. And that is typical one of these situations where it comes up to commercial people far away from the site. They only look at dollars. Do we really need it? Do we really need it? Today, this year. And then the poor guy from operations said, well, we don't technically need it this year, but. And then they shut it down. Done. So we kind of just resting our case, and there is more. There's sophisticated owners, and then there might be less sophisticated owners. There's also the owners that, financial owners. They get the 8%. We don't want to hear about it. We do not want to hear. And the asset management company don't want to take that battle because now their business case looks bad. They get the 8%. And now we're adding customer operations. Can't do that. Just going to pay for gearbox. Yeah.
Well, yeah, they like paying for gearboxes, clearly. How much is a pitch alignment typically to do in terms of time? Is it a day, an hour?
Depending on, again, if it's an older, let's just say V80, you have to go up and change the pit rams. Our measurement takes 10, 15 minutes. And then to get it, stop the turbine, get it done and go back again, might be an hour and a half, 2 hours. And we can remeasure, and then it's okay, and it's up running. So it's a 2-hour operation, worst case scenario. On a newer turbine, many of them, you have a tablet down tower. Siemens 2.3 on many of those. You can simply just put in on a tablet, put an offset in on blade A, B, C, and it's running. It's a 5 minutes, 10 minutes operation.
So I assume you can do multiple towers a day then. So you're talking about in a couple of days, you can do a complete wind farm.
Yeah.
And stop all the vibration, all the main bearing replacement issues, the gearbox issues, the foundation issues, the cabinet issues, in literally a couple of hours per tower.
We can for sure remove the root case in many of the cases. Again, it's not like one size fits all, but in many cases we could do that. And let's say when the turbines are between 8 and 12 years old, for sure 50%, or roughly 50%, are misaligned to a certain degree. The better turbines, Siemens 2.3, hands down, they're the least misaligned turbine, but it's still about 30%. But if they're misaligned, it's not too bad. Siemens has actually a part of their service scope to look after misalignment. As the only one, as far as I know, they have a bracket they put in, and that works somehow. It's better than nothing. It's not ideal, but it's, when I say okay, it's doable, way better than anything else. Some OEMs don't even have it in the service scope.
Yeah, I've seen mostly that. They don't have it in the service scope at all.
we also have a client where the OEM is supposed to look after that. It's a pitch-related turbine. I don't want to name the brand because some people might be guess where it is. But the OEM service agreement is supposed to look after that. But they don't do it. And then the owner said, well, I'm not going to pay for it because they should do it. We have done the whole campaign, so we have put it out there, and it's more than 50% of the fleet. And now we have done a project, we have followed it for 2 years. And of course, a hydraulic pitch will leak all the time. So the turbine we just adjusted 2 years ago, that's now misaligned again 2 years later. Not crazy, but it's been wandering. It's been misaligned again. But who's going to pay for that? If it's a part of the OEM service contract, but they don't do it, then the owner don't want to pay for it. But the owner's going to pay anyhow.
Right. At the end of the day, the owner's going to pay anyhow.
They just pay an extra gearbox.
Well, yeah, you can do a very inexpensive pitch alignment test, or you can replace a gearbox. There's sort of your choices right now. And I know, well, this is busy season for pitch alignment. As we get into winter and the ground freezes, and you guys can get out there and do dozens of turbines. What do people do if they have pitch alignment problems? They see their towers swaying or the rotor moving in unusual ways. How do they get a hold of you? How do they contact you?
Well, we have the best website in the world, so AC883.com.
Here's the rub. You can get this done, get the pitch alignment done now, right? When it's windy season in the wintertime in the United States. This is where everybody makes all their money, but you want to make sure your turbine is operating at peak performance, and it doesn't take much time to get this done. The problem is that if you wait too long, Lars and AC883 are going to be booked, and you're not going to be able to get them lined up to do this. So if you want to get it done, you better get on AC883.com or get a hold of Lars via LinkedIn and get rolling now. And the same thing for the blade repair season. I've had a lot of people contact Joel and me about blade repair season next year. We're trying to find technicians. We need a capacity. We got problems. We have Cat 4s and Cat 5s. We know they're coming. They need to be reaching out to AC883 also to get ready for next season, because otherwise you're not going to have anybody on site. So Lars, thank you so much for being on the podcast. It's great to connect again. And we're going to see you in Nashville at the O&M.
That's true. And the OMS down there in Nashville, that'll be interesting. So San Diego is the new Nashville, and Nashville is new San Diego.
I'm going to miss the ocean, but it'll be a good time in Nashville.
Thank you so much, Alan.